We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, today we will study about the new article of module 3, that is optical loss in photovoltaic cell, that is a well-known solar cell. What are the cause of this optical loss inside these solar cells and what are the solution? What is the remedy to prevent the optical loss in the solar cell? See, the optical losses chiefly affect the power from a photovoltaic cell, that is a well-known solar cell, by lowering the short circuit current. The input, we all know that in the solar cell is the optical light, that is the photon energy. If the particular utilization of this photon light has not been worked out by the construction of solar cell, then it will create this optical loss. Optical losses consist of light which could have generated an electron hole pair but does not. The major working of light is to create electron hole pair combination and to create the power to generate the electricity. But in the optical losses this does not happen because the light is reflected from the front surface or because it is not absorbed in the solar cell. So these are the major 2 reasons. The first reason is that the light is reflected from the front surface or it is not absorbed or penetrated inside the solar cell. For the most common semiconductor solar cell, the entire visible spectrum, that is consisting of wavelengths 350 to 780 nanometer, has enough energy to create electron hole pairs, and therefore all visible light would ideally be absorbed. Among the wide range of electromagnetic spectrum, the visible region will be easily absorbed inside the semiconductor solar cells, but there are also different regions or various segments of electromagnetic spectrum which can also be utilized to create more power and to improve the working efficiency of the solar cell. So let's see how the optical loss causes inside the solar cell. The major 3 sources of optical loss in a solar cell is given inside this figure. Number 1 is the shading by top contact coverage. The carbon taps or the black films which we have used, the metallic contacts, is also working as a resistance to prevent the light to absorb inside the solar cell. So that much area of the metallic contact, or we can say electrodes, are one of the major sources of optical loss. The another source of optical loss is the surface itself. The black film which we are usually visualizing over the solar cell is the another reason for optical loss, because the light is not able to pass out from that black film or the surface, and hence it is reflected back from the surface, as you can see from this figure. Moreover, in the third condition, that is quite interesting, in which The light is already absorbed inside the solar cell, but due to the reflection from the rear surface of the cell, see, it has already passed out from the front surface. Now it is inside the solar cell, but due to the non absorbing criteria of rear surface of the solar cell, we have the TIR, that is total internal reflection of these lights, and the solar cell can also not be able to utilize such reflected light waves, and this is inside the p-type semiconductor. The above front surface is the n-type semiconductor. Now, what are the remedy of optical loss in a solar cell? That means how we can prevent this phenomenon of optical loss in a solar cell, because it is quite important to create more efficient power of the solar cell. So number one, top contact coverage of the cell surface can be minimized, although this may result in increased series resistance. So number one solution is we have to reduce the number of electrodes on the front panel, that is on the n-type semiconductor. Number two, anti-reflection coatings can be used on the top surface of the cell. So what happens, the light waves which are reflected from the front surface will now be minimized, and more absorption of the light waves inside the solar cell will be implemented. Another remedy to prevent reflection is that the reflection can be reduced by surface texturing. This is most important, and more efforts have been made by the designer of the solar cells in this particular area to identify the particular texture design with which the reflection can be reduced, or we can say the net zero reflection, with which the maximum power efficiency of the solar cell can be identified and it can be utilized as well. The solar cell thickness should be reduced or should be improved, because the solar cell can be made thicker to increase absorption. Although light is absorbed more than a diffusion length from the junction, has a low collection probability and will not contribute to short circuit current. With this solar cell of higher thickness, we will have the increased absorption. So more absorption of light will result in the more number of electron and hole pairs generation, which will create the more power efficiency of the semiconductor solar cell. And the most important, this thickness will also not contribute to the short circuit current. And the last remedy is that optical path length in the solar cell may be increased by a combination of surface texturing and light trapping, with which the light waves which are incident on the front surface, or we can say at the rear surface, because as we have seen, the light waves we have arised in the contact with the rear surface have also reflected due to the non compatibility of n-type or p-type semiconductors. So optical path length is the major parameter on which one can work out for preventing the optical loss inside the solar cell. So this way we can identify how the optical loss has affected the performance of solar cell and how to prevent it with this much solution. You can carry out this article for your GTU examination for 3 marks or 4 marks question. Thanks for attending this lecture.